Guys, so John takes his car to a garage for service, receives his itemized bill. Find the total cost of servicing the car. Okay, 5 multiplied by 4.2, 21 euro. Okay, 2 multiplied by 450, 9 euro. 2 multiplied by 28, 56 euro for the brakes. 2 multiplied by 60. Okay, grand total. I say subtotal. What is it? 206 euro. Now, the problem is with this 206 euro is we're going to have to get 13.5% of it. Get your 206, multiply it by 13.5 over 100, or you could also do it by multiplying by 0.135. And then when you add them together, the grand total bill. Okay, that's grand. That's only took like 40 seconds, okay? It's really quick. Everybody alright with that? Okay. Now, next one. The bigger one. Kieran is wrapping a present in a rectangular box. How many faces has the rectangular box? 6. It's like a dice, okay? And if I was to shade this in like that, you can see the extra sides there now. The dotted line is like hidden. It's like the behind angle, okay? So it has 6 sides. Now, yes. It's 10 wide and 30 across, okay? So what I can do is something like this, okay? What I might do is I'm going to draw some separate rectangles, okay? This is the side rectangle. Everybody agreed with that? Okay, that's the rectangle at the side. Everybody alright with that? So that's the side rectangle. Now, what's beside the side rectangle? Is the bottom rectangle. They're joined together, aren't they? What is the bottom rectangle? It's 40 across and 10. Well, the first one was 40 by 30. This one's going to be 40 by 10, which means it's going to be a bit narrower, isn't it? So I'm going to do 40 by. Still going to do it as 40, but what you notice, it's a bit narrower, isn't it? Okay. Then what happens after that? Then that one is connected to one at the back. The one at the back is the same as the one in the front. So what I can do here is I can just grab that there, clone it, and throw it up here. Everybody alright with that? That's the other one. Now, looking at the middle one, I'm looking at the bottom floor. See the bottom one here? Everybody alright with that? What can you tell me about this here? What is it connected to? A red one here and a blue one here. Everybody happy with that? What's the size of the red and the blue one? Okay, so this edge here is the same as this edge here. And that's an edge of 10, isn't it? So I have to go 10 across and 30 out. So 10 across, 30 out. Give me a go at this then. 10 across, 30 out. Around that much. About there, yeah. The same height as that, yeah. And then also I need to do next is clone it. So just clone that. I can put that one at the edge here. How many sides do I have now? I'm missing one. I'm missing the another one of the center ones, isn't it? This one here. So I clone that one there, and I put it to the front. Now I can't really fit all mine in, I'm afraid. See if I can. Control G. Slide. There you go. There it is. Everybody happy enough with that? Okay. List any one pair of faces that are equal in area. So they're equal in area. I'd say the red one's equal to the blue one. Would you? So where's the red one? There, and the blue one is there. And what do we have to call indicate on your diagram. So just say, call that A and call that B, and you can say A equals B, or face A equals face B. Just anything to signify where they are. You could also do something like this. You could say that one and this one are equal areas. Find the surface area of the box. What does surface area mean, guys? Okay, now look at what each face is, okay? What's the center one? It's 10 by 40, which is 400. That's 400, yeah? This one is 30 by 10, which is 300. This one here is 30 by 40, 1000, which makes that one 1200. I'll just get rid of the mini measurements for a minute. And then this one here, 300 as well. And this one here, 400. And you add them all together, don't you? So it's 400. Do you understand I'm doing length by width for each one? 10 by 30, 30 by 40, 40 by 10. Yes, Barry? It's a bit variable. I think they've settled that 15 questions. Add these together. 800, 1400, 1400. Did anybody get 3800? Centimeters squared, if it's measured in centimeters, which it is. Okay, question 6. Okay, list the elements of A. What are prime numbers, guys? Can anybody tell me what a prime number is? It, one and itself. An example would be the number 7 can only be broken up into 1 and 7, while the number 9 can be broken up into 1 and 9 and 3 multiplied by 3. So 9 doesn't count. People often mistake odd numbers with prime numbers. That's not the case. So let's start off. What's the first prime number in this list? 2, 3, 5, 7, 11, 13, 17, 19. No, one's not. 1 doesn't count. 1 just isn't considered a prime number because it only has one factor, 1 by 1. While other prime factors, like example 2, would have 2 and 1. Yeah. Had to have itself and one other factor. Okay. So what about B?
1, 2, 4, 5.
These are the numbers that will divide into 20. Now in the middle there's going to be what numbers do they have in common? 2 and 5. Okay, what numbers are left in A then?
3, 7, 13,
And 19. Okay, what numbers are left in B? 1, 4, 10 and 20. Okay, what numbers did we not use at all? Did we use everything in this list? Did we? We didn't use. Oh yeah, but it's not in the. It's not on the list. So look, just want to make sure we've used everything in the list. 1 was used, 2 was used, 3 was used, 5 was used, 7 was used, 10 was used. I think we used everything on the list. So there's nothing on the outside. There's nothing outside, nothing inside U, but outside A and B. Now, what's A intersection B? It's what they have in common, 2 and 5. What can anybody tell me what intersection means in English? What do they both do, or what two things do they both have to do? You understand? What isn't or means you can do. If I said A union B, that means you can do. It can be either a factor of 20 or it can be a prime number. But if I say A intersection B, that means it has to be a factor of 20 and a prime number at the same time. That's the difference between intersection and union. Intersection, you have to be both. It's like me saying you have to be a good athlete and a good tennis player. That's intersection. If I say you can be a good athlete or a good tennis player, that means it's union. It's or. You can be both. You can be one or you can be the other. Does that make sense? Hopefully. Now, complete the sentence below. If an element is in A intersection B, it has two properties. It is a prime number and it is a factor of 20. It has to be both. The number 16 is added to the universal set. Place 16 in the correct region. 16 is not a prime number or factor of 20, so 16 goes on the outside. Okay. It's what Aaron said. It's not a factor of 20 or a prime number. Everybody right with that? Cool. 7. Write them to the nearest 10. 120, 200, 500. Write the 3 decimal places. 105. Round off 55 to 60. So 5560. That's 4 decimals. I only want 3. So what I'm going to do instead? 105, 5, 5, 6. This one here, it's already done, isn't it? It's already done. The next one, 0, 2, 6. Yeah. Now the next one, guys. 2 significant figures. I did this yesterday. Significant figures. As an example, how many significant figures does 30,000 have? 1 significant figure. How many significant figures does 32,000 have? 2. How many significant figures does 30,002 have? Has 5. When the zeros are sandwiched in between 2 significant numbers, they themselves become significant. If they're in a sandwich, they're significant. What about this one here? 5. What about this one here? 1. Okay, that's for big numbers. What about decimals? How many significant numbers here? 1. 1. How many significant numbers here? 1. How many significant numbers here? 3. The 0 is in a sandwich. How many significant numbers here? 1. How many significant numbers here? 2. How many significant numbers here? 3. We get the gist, don't we? Okay. You have to do it like that. It's hard work. 2,900 for the first one. Second one, 2 significant figures, 160. The next one, 0, 3, 4. The 2 significant figures are the 3 and the 4. Gonna remember that? They love using significant figures. Now, Karen went to a shop to buy 5 magazines. She had €10 to spend. She made an estimate of the total cost of each magazine to the next highest euro. That means that's €2. That's also €2. That's €4. This actually goes up to €2. That is €1. Add it all together, what you get, Ryan? I got 11. It says the next highest euro. It's not actually rounding it up or down. It says you have to go up. Keyword, next highest euro. Everybody alright with that? Okay. Based on the estimate, would she think she had enough money? No. Why would she not have enough money? Because no, because she's €1 short. Hasn't got enough money. Work out the exact cost of the magazines. So just add them all together. And what happens when you add them all together? 992. You're just going to add them all together, use the calculator, and you get 992. Everybody more or less got that one out, did you? Okay. Now, suggest which you think is a better method for estimating the total cost of the magazine. What's that about? Did I even say anything? Do we have to work out our own estimate?
Yeah,
Where does it say that?
work out the rest of the bottom
Where?
of the last six.
Work out her estimate. I did. Where does it say we have to work out our own estimate?
That's in the question. That's in
G. Suggest what you think. Oh, I did suggest a better method. Round off to round to nearest euro or nearest 10 cent even. So what would be the nearest? So what'd you say? Yeah, nearest 10 would be pretty good. Look, we'll try the nearest euro and see if it works any better. €2 plus €2 plus €4 plus €1 plus €1. What does mine add up to? Mine adds up to 10. And 10 is only 8 cents short. So that adds up to €10. Which estimate is better? My estimate is better. Why is my estimate better? As it is closer to 9.92. Is that right? €9.92. Now, question 8, the piggy bank question. How much money have we saved at the end of week 1? We started off with 20 and we added on 7, so we get. Oh yeah, sorry. You get 7, but then you have to take away 2 because you spend 2 of it on. You spend 2 of it on what's it called? Sweets, okay? Aaron. What we get here is how much money you saved at week 1. So we add on €5 and we get 35, 40, 45. What type of sequence is it when it goes up in fives? Linear. Okay. Now write down a formula in words to represent the amount he has saved, at how much in total he has saved at the end of each week. Oh, sorry, wait. Write down a formula in words to represent the amount he has saved at the end of each week. I'm interpreting the word he has saved, meaning the total money he has in his bank at that point in time. Would you agree with that? So I'd say it's total savings equals his total savings equals his equals €20 plus €5 multiplied by the number of weeks. Would you agree with that? €5 multiplied by the number of weeks you've been saving, added on to 20, gives you the total amount of money you have. Anybody get that? Anybody have a different answer? You could also, guys, argue that the total savings, call the total savings Y. Y equals €20 plus 5, and let X be the number of weeks. So it would be Y equals 20 plus 5 multiplied by the number of weeks you've been saving it for. So that'd be 20 plus 5X. Okay, that's another way of doing it. Kevin likes to buy a mobile phone for €100. Use your formula to write out how many weeks he needs to save. So look, we're going to use Y equals €20 plus 5X. Is that okay? Where X represents how many weeks you need to save for. What does Y represent? The total savings. What does your total savings need to be to get this phone? Right there, 100. So you replace Y with 100. Your total savings needs to equal 100. So you can say 5x plus 20 equals 100. Everybody happy enough with that? It's the same formula. 5x plus the 20 gives you 100. Bring over the 100, bring over the 20. 5x equals 80 divided by 5. 80 divided by 5. 16 weeks. Everybody happy enough with that? Okay. Kevin stops buying the sweets after 5 weeks. How much can he save each week after that? That's very easy. Just invest his €7. That's it. No, no, it's not that complicated. You make €7 a week. You usually spend €2 a week. If you give up sweets, you only have €5 usually. But if you stop spending your €2 on sweets, you have €7 for your just for your savings, so your grants.
Yeah, I would have. I probably would have read that wrong.
So Kevin basically thinks he can buy his €100 phone 3 weeks sooner. Do you agree? 3 weeks sooner would mean that he's going to buy it after 13 weeks because it was 16 weeks long. So what we're going to do is this. We're going to examine where he is after 5 weeks. After 5 weeks he's at €45. Would you agree with that? That's €45 at week 5. We can just count up in sevens really quickly, can't we? Do a really cheap way. That's week 5. Add on 7. That's week 6. Week 7. Week 8. Week 9. Week 10. Week 11. Week 12. Week 13. Week 13. He hits €101, which is enough to buy the phone, which is 3 weeks earlier than 16 weeks, which means he's able to do what he told us.